Alright, so what I'm trying to do is I'm trying to find out in what conditions does it take for the compensated demand curve to be more elastic than the ordinary demand curve. So we know that if we were to draw the compensated demand curve versus the ordinary demand curve, we know that, okay, so x1 would be on the x-axis and p1 would be on the y-axis. We know that if this were to be demand compensated, right, this would be demand ordinary. And the reason why is because it's less responsive to price change than the compensated demand would be. All right, so let's graph our second equation. I mean, not our second equation, sorry, our second graph. So, sorry, I'm not really good at drawing. Anyways, so here's x1 and here's x2. Let's start out with an optimized function. So, this is so ugly. Sorry. x1 star, x2 star, this is I over P1, this is I over P2. So, in order to show compensated ordinary, we know that the compensated demand relies purely on the substitution effect, where the ordinary demand curve relies on the total effect. So, let me continue on. Let's pretend that P1 goes down. Now, if P1 goes down, then we know that our graph shifts out. That is so ugly. So we know that the graph shifts out like that, right? And this would be I over P1 prime. Right? First, before we do anything, let's mark this as point A, because this is our original optimization point where we start out at x1 star, right? And this would be our P1 original. We know that the price of good one decreased because we said P1 decreased. So here's P1 prime. So what happens is that when we're graphing our substitution effect, it should land somewhere here, right? Because this is our compensated. So this would be x1 heart. I'm just naming it heart for the lulz. You can name it whatever the hell you want. So if we have this curve right here, let's just shift this curve in. It's a parallel shift over here, right? This would be A, and this A would correspond to this. This is our original optimized point. And now we have a second point from our parallel shift in. It would correspond to this compensated demand. And the reason why is because the substitution effect, again, is taken into account with the compensated demand. So let's label this A prime. Why not? Because the professor does it. And this point would essentially be A prime, right? So let's call this x1 heart because we called that x1 heart. This will be x2 heart, right? So let's make this smaller first. I know I'm spending way too much time doing this, but let's just make this smaller too. Okay, cool. Now that we have this down, let's go on. For us to get to part B, we know that at this price, in order for the compensated demand, to be more elastic than the ordinary demand, B has to be between points A and A prime, as we drew here. Let's call this X1 circle. And we can call, X1 circle, sorry. And it's at the same line through P prime, right? So for that to happen, our total effect is from A to anything that's on this new budget constraint that shifted out. So if we want X1 circle to be between X1 heart and X1 star, it has to correlate with this part where X1 circle has to be between these two lines, right? So if we choose this point, for example, this would be from A to B, which is the total effect. We would know for sure that X1 circle would be between X1 star and X1 heart. This would be the substitution effect, and this would be the income effect. So as a result, we know that from the Slutsky equation, which we don't even have to write down in this case unless they ask us to, the substitution effect dominates the income effect. And moreover, we know that partial x1c over partial p1 dominates the absolute value of x1 star partial x star over partial p1. Yeah. Also, if they're asking about, is there anything else I want to say about that? Well, if they're asking about normal and inferior goods, we know that from A prime to B, there's a parallel shift out, so real income raises, yet B is decreasing, yet point B is decreasing in terms of X1, so we know that X1 is inferior. Sorry about my poor writing and crappy video. Yeah, I'm just trying to do this. Okay, that's about it. Yeah? Yeah, cool.